Okay, this video is going to be about square roots of fractions. Okay, so here's what we've learned previously. If you are dividing two square roots, like the square root of a divided by the square root of b, you can write that as the square root of a quotient, a divided by b. So you can take two of them and write it as one, if you want to. Now, the reverse also works. If you have the square root of a quotient or a fraction, if you want to, you can break it apart and do the square root of the numerator divided by the square root of the denominator. It all depends on what the numbers are. Okay, so here's one example, and it's the square root of 2/5. So we have 2 divided by 5. That does not divide evenly. So let's break this one apart. We'll make it the square root of 2 divided by the square root of 5. Okay, now that's not simplest radical form because we have a square root in the denominator. So we are going to rationalize the denominator, and we'll multiply the numerator and the denominator by the square root of 5. Okay, so now when you multiply the numerators, square root of 2 times the square root of 5, that'll be the square root of 10. And then down here we have the square root of 5 squared. So that's going to be 5. All right, that will be simplest radical form. Okay, remember you can't simplify with the 10 and the 5 because the numerator is not really the number 10, it's the square root of 10. Okay, let's look at this one, the square root of 1/12. Okay, so this is another good candidate to break it apart. We have the square root of 1 divided by the square root of 12. Now, you could multiply the numerator and denominator by the square root of 12 right away, but usually it's better if a square root simplifies because there's a square in the radicand. You should do that first. So if we did the prime factorizations for 12, that's 2 squared times 3. So really in the denominator, we have 2 times the square root of 3. All right, now the square root of 1 is kind of a special number. You can either leave it as the square root of 1, or that does just equal 1. Okay, now when we are going to rationalize, we'll rationalize by multiplying by the square root of 3 over the square root of 3. So this, generally speaking, is better than back here if you'd multiply by the square root of 12 over the square root of 12, because 12 is a larger number, and that could make the problem more complicated. Could. All right, and then we'll just multiply. 1 times the square root of 3 is the square root of 3. And here we have 2 times, we've got the square root of 3 squared. So that's going to be 3 times 2. See, we're doing 2 times 3 in the denominator. So that will give us a 6 in the denominator. Okay, and let's look at one more. The square root of 6/49. Okay, so if we break this one up and say the square root of 6 divided by the square root of 49, it's a good first step. Now, a lot of people would not look carefully at this, and then they would do multiplying by the square root of 49 over the square root of 49. That leads to kind of a big number in the numerator. This is way too much work. Look carefully. If you have a perfect square, like 49, the square root of 49 is just 7. So this really is just the square root of 6 divided by 7, and then that's the answer. That's the whole problem. So you want to look out for when those kind of numbers pop up, and they will. So if you have the square root of 4, you can just put 2, or the square root of 9, replace it with 3. Square root of 16, 4. Square root of 25, 5. Square root of 36, 6. We just did the square root of 49. The square root of 81, 9. Oh, I left out square root of 64. If I'm going to go in order, that would be 8. So, I mean, there's a lot of them, but those are the common ones. Okay, so one last thing to just make sure that you're clear. You want to put your answers in simplest radical form. Here's some examples that are not in simplest radical form. And what's wrong with them? Okay, in the first one, we have a square root in the denominator. Okay, basically you have something irrational in the denominator. That's the problem. You can't have that. Okay, this one, we have a square root under the fraction. Can I have that in your final answer? So it's irrational under the radical. Can't have that. Okay, so either say an irrational or a square root if you want to talk about that specifically. So no square root in the denominator, no square root under the radical sign or the square root sign in your final answer. And the problem with this one, the square root of 40 divided by 3, is that 40 has a square in it. Okay, so 40 really has 2 squared times an extra 2 times 5. Okay, so no, you can't have a square under the square root, all right, in simplest radical form.